I'm Haotian from Rutgers University, and today I would like to give a lightning talk about our project Diamond, which is a user-friendly platform to allow the user to democratizing and simplify the large foundation model training for science. So we all know that the past decades, maybe especially the past 5 years, especially after the large language model begins, the US government has made a significant investment in supercomputers. For example, the uh, Tech Horizon and the Permuter at NERSC, the Polaris and the Aurora at Argonne, the Frontera at Oak Ridge. So all those supercomputers are pretty powerful, but they require the user has a background in supercomputers and are not easy for those scientists, I mean domain scientists, to use the supercomputer to do their scientific research. So, for example, we can find the key barriers that abandon those domain science from using supercomputers. We use the AlphaFold 2 or OpenFold as an example. First, you need to install the software and all its dependencies. And you need to correctly write a Slurm or PBS job to submit it to run it with many nodes with many GPUs. You need to manage your job once you met a failure, which is quite usual in training process. You need to recover it from a checkpoint, and you need to manage all the data. Some scientists are not familiar with the file system in the supercomputer, so they need to spend some time on this, and all those difficulties made those domain scientists need to spend too much time in research how to use a supercomputer. And that's why we need Diamond, which is a platform. We want it simplify the process to train any model with any data sets on any machine. But actually not any machine. It main focus on the NSF HPCs. So our goal is to produce a user-friendly, efficiency, scalable, interoperable, and such a platform to make it easy for scientists to employ deep learning on HPC clusters. And here is the Diamond architecture. The key components is the Diamond core. We have a Diamond front-end interactive with users. Users can click some buttons and type in some input box to determine their jobs and their dependencies. They can use a drop-down box to select their clusters and their the queue they want to use. Everything you need to finish it with Slurm can be implemented by Diamond. We also provide a simplified process to allow the users to build a containerized environment by using Obtainer or other container in the supercomputer to wrapper all the environment and the dependencies of the application. And then we will submit them to the Globus compute. Via the Globus compute and Globus data transfer, we can pass all this data to the supercomputer and feed the result back to the users. And in our backend, we have image manager, task manager, and the supercomputer manager, which allows users to store those metadata, determine the image and the task. The supercomputer manager is designed by our development team. We can write some configures on each machine because different supercomputers may have different config. For example, some support Slurm as the job manager, and some support PBS, and some use Obtainer, some does not, and some use Minifork, while others use Condas. So all those environments are configured in the supercomputer manager by our dev team. So user can ignore the difference for simplify their migration. And this is the Diamond front-end user interface. here is the process for the image builder. In here, users can select the endpoints, and then we will loading all the partitions in these endpoints in these supercomputers. And select the available account, and user then can define a container. It can pull from the Docker or some other hub like the obtainer hub. And then user can input their dependencies like the pandas or numpy and some build commands. Then just click a submit. We will build the container in the supercomputers and will return the log to allow the user find if there is something wrong. And once it's finished, user can submit a job via the pre-built environment, the containerized environment. The endpoint, all the same. And here you can determine your task name, duration time, and the container environment you've just defined. And then you can use some task scripts to run this job. For example, your command line you want to use in your Slurm scripts. And here is the results. We have 6 PhD students compiled with you. All those participants are familiar with HPC, but even for them, when let them building the open folder from scratch, they have some difficulties without using Diamond. But with using diamonds, all they can finish this in 5 hours, even from the base. That means do not use the pre-built containers. And we can find that we do significantly reduce the time for user to run deep learning workflow. And we current process we have supported for these 3 machines, and for the Delta and the Vista, we are in the progress. We would like to release the alpha release on next month. And if you are interested in our project, you can following our website URL to see the first alpha release. And that's all. Thank you.